In this video I'm going to show you how you can check if two variables are correlated. So that is, if we know one thing, can we predict something else based on that? So in this example we've got hours worked and the pay. So if we know the number of hours worked, is there something that we could use to predict how much you're paid? And of course that is your hourly rate. So here we can see it's, well, £7 or $7 an hour or whatever. But then down here something weird goes on, which is you've got the concept of overtime, so you're getting £9 an hour later on for working over 28 hours. So there's another complex effect here going on. And so how do we show that in fact the hours worked and pay are correlated? Is it an accident that the more hours you work, the more you get paid? Is it just completely random? Is it a random number generator that your boss presses and it determines how much you're paid based on the number of hours by just splitting out a random number? Or is there some system behind it? And of course there is some system. And if you draw a graph, so we'll just go insert and just stick a graph. This is OpenOffice, in case you're curious. Very cheap free software that's actually acceptably good. So here's our graph. Looks pretty much like a line, so this is strongly indicating that those two things are linked. Now we insert a trend line, so this is the best fit line, and it'll be plotted using a thing called least squares, and you can see that the line is a pretty good representation of the data. So if we have a really good line, we can say with confidence that if we use that line to predict, that the prediction is reasonable. So if we say 40 hours and we come along this line, we're going to be reasonably confident that our guess is pretty accurate. And the way we can quantify how good this line is, rather than just looking at it and going, that looks good, and not being able to tell kind of the fine detail, we can use a thing called Pearson's R, or to give its full name, Pearson's product moment correlation coefficient, which is this here, and you can have built-in functions. Like in this one, there's just the function Pearson, and that does the calculation for you. And in this case, we've got Pearson's is 0.998. Now, if this is 1, it shows a perfect positive correlation. And the fact that this is extremely close to 1 suggests that it is extremely likely that these things are correlated. So let's look a bit closer at Pearson's R to understand how it works. And here's some examples that will make Pearson's R very clear. Okay, R equals 1. This is absolutely perfect. Every single data point is perfectly on a line, so we can represent that data absolutely perfectly. So we can be extremely confident that if we say pick a value 6 and read it off that graph, all our data is indicating that that prediction is likely to be true. That we can in fact infer something from the correlation. There is clearly some relationship between this and this. However, Pearson's R can be negative. It's a value between -1 and +1. And a negative suggests that the things are negatively correlated. So here, as this thing increases, whereas here, as this increases, this thing decreases. If we've got something that's not quite perfect, you see this looks like a decent representation of the data. Like in our previous example, we would get an R that's less than 1. So this is quite close. That point's throwing it probably. But we can say sort of there's clearly something going on here. There appears to be a link between this thing and this thing. Whereas here, it's just completely random. This line is just a joke. It is not representing the data at all. If, for example, if you're going, if this thing is 8, that means that must be maybe, I don't know, 22. And whereas in reality it's maybe 1 or 2 or perhaps 3. It's not a great graph. And so using this line to predict is just totally absurd, and that's why Pearson's R is 0. It's just saying there is no relationship. There's no way that we can use this line to predict this. So there you have it. That's how you can use Pearson's R to show a correlation. And now Pearson's R is quite good at showing that there is probably going to be a correlation. And it's limited to linear. These are straight lines. So if something is some sort of curve, or if it's, for example, if your hours worked was proportional to the logarithm, your pay was proportional to the logarithm of your hours worked, you'd have to use log graphs to see that correlation. So you simply relying on this purely will cause you to miss some more complicated things, but in sort of sociology and psychology, generally you'll be able to pick up on the correlations using this, and it's a good first test. What I'm trying to say is Pearson's R is very good at showing, yes, there is very likely to be a correlation, but it's not proof that there is no correlation always. You have to be more skeptical. So it's a good initial test to show that two variables are correlated. It's related to linear regression. So hopefully this tutorial is helpful to you, and you can now go away and look in the correct places to solve the problem, perhaps a dissertation. And finally, thank you for watching.